Hello. I'm David Jones. I'm a software solution architect for SoftAtHome. I'm working for SoftAtHome for the last 8 years. So what's SoftAtHome? SoftAtHome is a company owned by, operated by a club of operators. We do hardware-software separation for the operators. How do we do this? We have our own Linux distribution and middleware stack. As you can see, we are deployed in 22 million homes over 35 countries. And we have almost around 46 million licenses on the set-top and the gateway, and 5 million licenses on the mobile agents. So what I want to talk to you about today is about network topology and device identification. What is this? That's actually a good question, because if I talk to people here, I get multiple different answers. What you can see here is, for example, something that everybody will have in his home. That's the home gateway. Depending on the size of his home, he will have one or multiple repeaters. And you will find, of course, mobile devices, fixed PCs. They are either connected to the private LAN or to the guest LAN. They can also have a laptop, a hard drive connected to the gateway, or a printer connected to the gateway. And depending on his subscription, he can have FXS or DECT phones. And what we also lately see is a lot of IoT technologies popping up inside the gateway, like, for example, Z-Wave, ULE, UE, and Zigbee. So why do we need to have a better network topology and device identification from the gateway part? First and for all is to improve the end user's information, that he gets more precise information, and to provide more detailed information, and to improve the quality of the LAN network. For example, if you can provide the end user with detailed information about the device, like instead of just providing a MAC address in a web UI, but you can also provide him with the name of his device, what type of device, the IP address, and, for example, the Wi-Fi signal strength, he can most likely solve most of his own problems. Like, for example, in the web UI, you can see that the Wi-Fi signal strength is bad. He can make his own decisions, like, for example, to move the device closer to the access point, or to buy an extra extender inside the network. And in the end, this will reduce the cost for an operator for the help desk. You can also use better device identification for adaptive steering algorithms, that you can push a specific steering algorithm to the device instead of trying to automatically detect it. What you also can do is generate for the operator reports, like, for example, which are the most used devices inside the home, or more importantly, which are the most devices that are behaving badly inside the home and who are causing bad Wi-Fi performance. All these metrics can then be later on used to improve the LAN, so that the operator knows together with the vendor where the correct points need to be addressed. And last but not least, if you have proper device identification, you can also push tailored security rules to the gateway, like, for example, for IoT devices. You can push dedicated firewall rules for them, and for QoS, If you can detect there is a set-top box in the network or a gaming console, you can do the appropriate QoS configuration. So, how did we, as SoftAtHome, address this problem? I think we had tried to address it like 5 or 6 years ago when we developed gMap. gMap is for us more than just a device identification and network topology system or database that you want to call it. For us, it's actually more like an open framework, a framework that other applications can use to get real-time events on what's happening on the interfaces, the virtual interfaces. And as you can see here, it's not only the fixed and the wireless interfaces that we are addressing, but we are also addressing what's connected through DECT, SIP phones, USB. So actually any interface that's connected to the gateway, we are trying to map and show more information to it. So this is a next slide of topologies that we have integrated in gMap. USB, PLCs. PLCs, it can either be through 9005 or through HomePlug AV. Multiple discovery protocols, like for example, LTD coming from Microsoft. We implemented a lot of home automation technologies, ULE, Z-Wave, Bluetooth Low Energy, KNX, UE, you name it. We are all mapping them. And virtual devices, like for example, UPnP, USB devices, like for example, a logical partition on hard drive and stuff like that. Now, to come back to network topology, what's basic network topology from a device point of view? It's trying to get the MAC address on the physical interface and then trying to map it out in the system. And depending on the protocol, you can distribute this information from one device to another device. Like for example, you have here the internet, who is connected to the gateway. It's a little bit difficult to show, but the second one on top is the gateway. And the gateway can have a LAN network or a gas network. This will then top in a LAN bridge or a gas bridge with each their own interfaces below it. And depending if there is a device connected to the interfaces or not, you can see that the system is detecting the devices. Like, for example, you have here the W1 interface, where there is a wireless repeater connected through it, and either by using 9005 or our own SSWI protocol, all the layer 2 information and the connected devices of that repeater are being reported back to the gateway. So, a brief introduction on how you can do this for Wi-Fi. For Wi-Fi, you can use the Wi-Fi association list. And for Ethernet, you can use the bridge forwarding table. So now let's talk about a little bit about device identification. Again, here, all the information about the devices, they are stored inside gMap. We have, and gMap is collecting from the devices all different fingerprints. Like, for example, HTTPS, UPnP, user agents, DHCP, you know, all the common metrics to identify the device. They are stored inside gMap. They are reported back also to our ISONs, our metric monitoring platform. But to know which device it really is, it's actually our DIL, who is our device information lookup system, who can either use a local database or a cloud to figure out what this device really is, like, for example, an iPad Air 2 or a Samsung Galaxy S8, for example. And that information is reported back to gMap and also replied back to the monitoring system. So it's a little bit hard to see, but this is the metrics that our DHCP client is gathering. You can see it has all the DHCP options that has been sent. It has information about the lease time, and it has information about the host name. And for an example, I have also included statistics coming from our UPnP discovery service running inside the gateway. Here for metrics monitoring of the device identification, most of the people, they are looking at server agent and also at the model description. That's very helpful to figure out what the device really is. So how does this high level all work? We have here the maintainer of the system, gMap core, who has multiple gMap clients connected to the system, who each client does their own specific task to enrich the topology. For example, the gMap client is talking to the DHCP server to get the necessary fingerprints and relay to the core, and the same thing for the UPnP client, who is talking to the UPnP discovery service. Small overview of all the different plugins that we have here. I think we went almost over all the fingerprinting technologies, and for PLC monitoring, we have HomePlug IV and 9005. So how does this all look like inside the data model when all this information has been collected? This is an example of how it looks for my Synology NAS at home. So we have the typical structure, devices, .device. And here for an Ethernet device, the MAC address was chosen as the key. We have the friendly name that can be used for the web UI, the device type that can be used to figure out what the device is. And here in this example, you have the client ID, the IP address, the DHCP. So all the useful parameters that are being monitored to give towards an end user or a monitoring system. You have here the example of the device names. So for example, this device was first detected as a PC, but then the MDNS module said, no, I don't think this is a PC. For me, it's the name should be disk station. And then the end user said through the web UI, I want to have Synology NAS as the name of the device. So depending on the priority system that you have here in place, multiple systems, gMap client plugins, they can do a suggestion of the name. And depending on the priority, the final name will end up at the top of the tree. Here we have the same example for the device types, where we first thought it was a computer. No, MDNS said, I think it's a printer, because it's being announced on the through MDNS as a printer. No, the UPnP says, no, it's a media server, because there is a media service running on it. And through the web UI, I said it should be a storage. And we have the same thing for the multiple IP addresses that we can collect from a device. They are all being stored, and the same for IPv6 addresses. And here is an example of all the DNSSD services that are being announced by that device on the network. As you can see here, it's mostly file sharing that is being announced, printer service, and I think also media rendering, no media rendering through DNS, it's through UPnP, and the web service. So which are actually all the use cases that we have built around this system? Of course, we did network topology, and I have the same problem as Wouter yesterday. A lot of things are just not showing up on the screen. But on the left side, you can see the topology of the gateway. In the middle, there is normally the wireless repeater. And on the right side, you can see that there are which devices that are connected to the repeater. So depending on the skills of your web UI team, you can build a lot of nice topology information web UIs around this technology. Presence detection. Using this system, it's very easily to do to have a kind of a presence detection UI inside your framework, because if the device is actively working inside the network, and if you assign, for example, here the user Mirsha to this device, and the device is active on the network, you can assume that the device and the home user is at home. Parental control. Parental control, the same problem. You need to have a user configured in the system, multiple users when it comes to a family, and you need to have a UI able to assign devices towards the user. And with this technology, it's easy to do this. In the end, you can say this device is then permanently allowed on the internet, blocked, or has schedule-based access. Security profiles. Here is the same thing over again. What do you need to do? You need to know which devices needs to be monitored inside the network. And when you are discovering a problem with the device, you need to have a system to report back to the device, to the rest of the system. Look here, in my case, my Raspberry lamp, that it has been compromised. Smart Wi-Fi, backhaul selection. What's the problem in a smart Wi-Fi home? It's actually to know, when it comes on selection of the optimal link, is to know which path is the most performant path. Like, for example, on the left side, you have a connection made through Ethernet and to Develo home plug devices. On the right side, you have a network being made purely through Wi-Fi uplink. And here, this repeater needs to make a decision which path is the best path. If you are only going to look at Ethernet or Wi-Fi, you could make the decision, the right side is Wi-Fi, so that's going to be slower than the left side because that's actually Ethernet. Because that's actually the only thing that the repeater sees. It's Ethernet, and my Ethernet uplink port is up. But depending on the technology, you can try to figure out that there is actually a PLC device between it. And if you are going to ask the statistics of the real link speed between the devices, you can make the appropriate decision. Here's an example of QoS, device prioritization. This is a feature that we developed for one of our customers, where a user can make the decision on, I want to give this device a higher priority than the other device. Same problem on to display the devices inside the UI. And since we are using gMap, we are setting the appropriate flag inside the device topology. And in our case, the QoS management system is using the gMap framework. So that means he has an open query asking gMap, can you return me back all the LAN devices with this priority flag set? From the moment it's being set by the web UI, it's getting back in real time an event, and the QoS management module can make the appropriate decisions. IoT. We use this system to make for an agnostic system that a web UI can control the IoT devices without being, without the UI need to know which technology is behind it. So that means that we are creating generic functions like lamp off, lamp on inside the system, and this can then be used. Are there any more questions? Oh, sorry. I hope this one is working.
So probably a couple questions. You know, you've seen this request to start driving applications down into a smart router or a residential gateway. Do you see this as a natural extension of topology?
Excuse me?
So as you see additional services being driven down into the router or into the home, do you see those as being a natural extension of topology? These services usually will carry IP addresses, services connected locally or potentially into cloud. Do you see this as a natural extension?
This can be extended by this as well. So that means if you are connecting the interfaces that you have typically inside a container, and you allow the system to map them, then you can map and say in your topology, look, this is a container running, and at this end of the container, I see this MAC address assigned to it. So you can extend it also for that part if you want to.
Excellent. Right.
So basically for us, in all the examples that I've shown you, this is actually a high-level API, because if it comes back to applications, an application, they need to know which devices are available inside the home, and depending on what you want to do, like for example, prioritization, monitoring them for security, presence detection, that's actually second what you can do with the parameters that you are making available.
Excellent. And so the second question I have is gMap and your APIs going to be contributed back to prpl?
Yes, and we, in the presentation from yesterday, we have released all the parameters of this system, the complete data model towards the OPMap project of Broadband Forum.
Oh, fantastic.
So the data model and the complete API is already available.
Excellent. Thank you.
Can you?
Yeah, thank you. Basically, I will ask from here. My question is regarding what about the privacy? So basically, all the devices that are connected at user home are expanded to the network, to the cloud. So at least some kind of agreement with the user, because your cloud will contain all the information about the types of devices, the security devices at home of the user. So it's like additional breath to the attack or something like this.
Like I said, there is a possibility to have a local database and a remote database, and depending on what you want to opt in for, you will have this part of the services available and not, because like you said, for privacy, there can be some concerns, but all the data that we are sending towards the cloud, they are being anonymized.
Thank you.
Okay. Do we have any other questions? I just want to say thank you to the audience. You are clearly a self-organizing audience. That's very nice, since I missed the queue. Thank you very much, David. Very informative. Thank you.